So, thanks for the introduction. I will try to keep the presentation short and will just briefly explain about the virtual climate chamber we have. Okay, so as also previously mentioned before, that we have a virtual climate chamber in one of the BOL lab in the second hall. And it basically is, as the word says, it's a climate chamber where we can have different artificial climate inside the igloo-shaped climate chamber. And the idea behind this that we have a project with our team partner from TU Berlin in the HRI Institute, where we are researching how the indoor environment quality is connected with the energy consumption. So indoor environment quality is a factor where it includes lots of different variables, including acoustics, thermal comfort, air quality, light, and some other parameters. And ideally, if we have lots of energy, we can pump lots of cooling into a house or into or heat up a building a lot of much, and that will make us comfortable, but it will be really bad for the environment and the energy consumption would be way too much. So with this climate chamber, one of the main goal would be to try to find an index or a ratio where we can combine both of these parameters and have a variable which will tell us that, okay, this is too much energy consumption in the factor that we will make the human being comfort, but it's way too much energy and we should try to have a different approach. We are using this chamber in which the user can sit inside the climate chamber and can experience different room models using the virtual reality technology, and can also interact with the room models, which would mean that if the interaction includes opening a window, then we have a building energy simulation software combined with the VR room model, which will get the notification that, yes, a window is open, and the energy balance would be changed, and the building will and the climate chamber will change accordingly. This is a very simple idea in which we combine the building energy simulation software with the VR environment with Unity and Modelica. And then Modelica is actually acting as a brain, which then tells the climate chamber via OpenHub and the Arduino devices that the room model should be heated up or cooled down, or if the window is open, then, for example, if the outside climate condition is really cold, then we should have cold air blowing into the climate chamber or hot air in the other conditions, and it goes on like this. This approach is also portable. There are different climate chambers in the different parts of the world, but this is the different parameter that it's portable. We can pack it up and we can shift it from one place to another. We also tried it more than one time. And all the air conditioning units are consumable devices, so we can buy it from market, we can use it, we used it, and they are hacked from their infrared remote control. We hacked them, and that's how we are controlling them. Our partners in the TU Berlin, they're making the second prototype, which is static, which is it's not movable, and they are using the industrial scale air conditioning units to flush out really quickly the air temperature, the air inside the climate chamber, and this will be more dynamic as compared with the chamber we have, and it will be definitely more powerful. In the future steps, we will include more VR scenarios, so we can have more spatial boundaries. We can have more, like, for example, 2 rooms, one would be air conditioned, one would be not air conditioned. We also want to include surface radiations into it, so that if the user is sitting inside or standing inside, it could also be able to feel the surface radiation coming from the surface in VR environment, but in reality in the climate chamber. And I would like to present a video now from the link. That's the climate chamber in the other hall. I think you will be able to see it in the afternoon session. This is just one example where the user can actually see inside the virtual environment. And just a very basic example, this is just one room where you can go inside, interact with the surroundings, can have a look around, and this could be also multiple rooms, multiple buildings, also a city scenario. And in this case, he just opens the window, and then we have our coupled real-time simulation engine, which actually receives the information that the window is open, and then it starts changing the energy balance. And we have certain devices which can help you feel that, okay, the window is open. So depending on the outside conditions, we have cold air or hot air blowing inside. And this is our second extension, in which the user can also feel the radiation along with the air temperatures and the airflow. In case if the user also turns on the heater, then that user should also be able to feel the heating effect of the heater, or if the window is cold, then also the cooling effect of the cold window. Since we have the simulation engine running in the background, we can always record the data sets and the human behavior, how the human interacts with different kind of temperature scenarios, and then we can continue with the studies, also subject studies, and can do more research about the human behavior in that. Okay, that's all from my side. Thank you very much.